And we can pick this 18 millimeter plane, so that way the flange goes right down to that plane. That's pretty sweet to reuse that plane. And then for the length of this thing, we're going to say partial flange. Now, the thing about sheet metal in Onshape with partial flanges is this distance by default is this distance here, which is not what we want. So that distance there is 10. You'll see if I change that distance to 15 or 20, it increases off of that edge. So instead, what we want to do is we want to change this to end condition up to entity with offset. And then you just pick this point here where you want your dimension to begin. So our dimension that's shown on the drawing there is 31.5. So if we make this 10, you can see it's getting bigger, 20, and then 31.5. I only did those increments so you could see what's going on with it. And then remember, in Onshape, you can pick both edges at the same time. So I can also pick this edge over here. So if I come back up. Hey, what's up everybody? Too Tall Toby here, and in today's Onshape sheet metal step-by-step tutorial, we've got an awesome challenge, the SM Lifter. This tutorial is jam-packed with tips and tricks, and I'm very excited to get into it. And before we do, I just wanted to remind you, if you're out there in the world trying to learn 3D CAD or trying to learn sheet metal, we have a fantastic resource for you over at tootalltoby.com. If you visit us at tootalltoby.com, you'll find a library of over 200 2D to 3D CAD challenges, and you can filter this library based on sheet metal challenges. So you can get in there, you can take a look at some sheet metal drawings, you can try to turn those into a 3D model, and if you get stuck along the way, you'll be happy to see that we've got a library of community tutorials from other members of the community posting in a variety of CAD systems. So what better way to learn than to challenge yourself, to get stuck along the way, and then to watch a tutorial of somebody else solving that challenge. I think that's an awesome way to learn. I hope you do too. I hope you can leverage this resource, and I hope that you enjoy today's step-by-step sheet metal tutorial. tootalltoby.com. You can go to tootalltoby.com, sign up for a free account, and then you can access the full library. And up here at the top of our library, sponsored by this week's featured challenge practice model sponsor, macropad.io. They make custom macro pads for a variety of 3D CAD systems. We can see that there's a brand new premium practice model that's available for all users, and we can click here to practice 2507-10. You'll notice here that no one has solved this yet because we just released it like a minute ago. So let's click here to begin and go. So the question is, what is the mass of this part in XXX grams? And we're going to try and enter that mass right down here in the Practice Models app so that we can earn a point on the Practice Models leaderboard. So even though the clock is running, what I like to do before I get started in Onshape is I like to come up with a game plan as to how I'm going to model this part. So we can see here that this part is a sheet metal model. And when you're working in sheet metal, one of the first things that you want to look for is what your very first sketch is going to look like. And in sheet metal, we can perform a function called sheet metal extrude. And so what that means is we could maybe start out with a shape like this, and then we could take that whole shape and we could extrude it, and then we could fill it off these top corners here. But the thing is, I don't need to do the entire model. I could opt just to do half the model. So I think my very first sketch is going to be on the front plane. It's going to look like this, and then I'm going to fill it that shape off. I'm just going to do the sheet metal and extrude that out for half the model, and then I'm going to fill it that shape off. Then once I've got that shape filled it off, I'm going to punch this hole through the middle, and then I'm going to get to work on this shape here. There's like a tab that comes over and down and over. But before I'm going to be able to get that tab in place, I need to create the clearance for that tab. So there's a little bit of jog clearance, or they call it a relief cut here on the drawing. So 24 millimeters to the start of that relief cut. So maybe looking down on the top, you could imagine that this is like a rectangular shape. But the thing is, the jog itself starts from a different location. So you'll notice here that the relief cut that we just talked about, starts here at 24 millimeters, but the jog itself begins at 30 millimeters in here. So maybe when I go to create that cut, to create the cut for that jog, maybe what I'll do is I'll actually create the cut to look a little bit more like this. I'll come over, down like this, and then up like this, and come over, so that I begin right away with the kind of starting point at 30 millimeters for that jog, for that flange that's sticking down. And maybe that'll save me that extra step of having to create a sheet metal tab. Then we get into probably the most complicated part of this design, which is going to be to create this jog that comes down here at 60 degrees and then comes back over at another 60 degrees or 30 degrees, however you want to say it. So we need to create that jog shape there, and it needs to go down to exactly 18 millimeters. Well, I think what I'm going to do is I'm going to create a plane that comes down 18 millimeters, and that's going to represent kind of the absolute floor, because that's also the bottom of these little tabs here that are sticking out on the side. And then when it comes to creating these tabs, we'll talk a little bit about Onshape sheet metal and how you can control the length of your flange, and we'll finish up with a super secret shortcut on how to fill it off those corners. So that is our game plan. I know that we took a couple of minutes there to come up with that game plan, but I think it's always important to start out with a game plan and then get into your actual 3D modeling. And if you agree, be sure to hit the like button on this video. So let's move this drawing over to our second screen so that we can model this up and we can see all of our dimensions. And let's bring up our copy of Onshape here so that we can work in Onshape. And let's bring up our keyboard cam as well, so you guys can see all the cool keyboard shortcuts I'm using. Now remember, over on the left, we've got some live chat. We've got some people over there in the chat that are also trying to model this thing. So here we are in Onshape. I am using the free version of Onshape here, but if you and your team want to try out Onshape for 6 months, you can visit us. I've got a link down below where you can visit us and you can get Onshape for you and your entire team for up to 6 months. But here you can see I'm using the free version of Onshape. I'm going to say create document, and I'm going to name this document 25-07-10 space SM lifter. And the thing that's cool about Onshape is that I am going to store this in the public space. So here's the public space here, and that means that anybody with an account on Onshape can go into that public space and can search for this text string here, and then you could open up my model and poke through it in case you're coming up with an incorrect mass. So I'm going to say create public document, and the first thing I always do is just take a look at my workspace units. Now my default workspace units are millimeters and grams, so I'm pretty confident that I'm in the correct units, but just in case you didn't know how to do it, you do it up here in this hamburger menu. And so once we set our workspace units, front plane, S key, begin a sketch, N key to get normal to, S key, begin the line command, single click, move my mouse over about 169/2, move my mouse up here about 66, and then I'm going to hit escape and I'm going to press the S key and I'm going to create a line here, and this line is going to be a construction line. And what that lets me do is it lets me create a dimension here, so S key dimension, that goes from this line to this line, and then I can cross over that line and I can make that distance there 169. So even though I'm not doing a revolve, I'm doing a mirror later in the model, this is a great way to get doubled dimensions. So now for the height of this thing, what I could do is I could add in a dimension here from the base up to this point, and I can make that height 66 millimeters. But I thought this would be a great opportunity to just talk to you for a minute about Variable Studio. And you'll see why here in just a moment. And I don't want to go too in depth on this topic, but I am going to create a Variable Studio here. So I'm going to get rid of that 66. I'm going to exit this sketch, and I'm going to come over here to this panel over on the right. And once I click on that panel over on the right, I'm going to click down here at the bottom, Create Variable Studio. And then what this lets me do is up here in this Variable Studio, I could create a dimension like width. I'll call this one width. Width of base. I'll call it that, width of base. And then over here for the length, I'm going to input the width of the base at 66 millimeters. So what that 66 millimeters is, sorry, I misspoke here. What that 66 millimeters is this dimension here. And the reason that's significant is because when I go to create this fillet here, this fillet is going to be 1/2 of this width here. And so by creating a Variable Studio, I can create links like that in my Onshape project. I got a little ahead of myself, and I kind of confused this 66 with that 66. That was just kind of ignore that. So I'll go back in and add that in the sketch here in just a moment. But we are going to see that when I go to extrude, I'm going to reference that Variable Studio by typing in hashtag width, and then I'll get that width of base. And then when I go to input this dimension here, I'm going to type in hashtag width, and then that one will be over 2. And that way, if I ever change the width of this dimension here, that fillet will automatically update, and I'll always get 1/2 of that distance. Now, I know with a fillet, this could also be maybe a full round fillet, although full round doesn't always work the best in sheet metal. However, there are plenty of applications you can extrapolate this skill and use to save yourself some time. So I've gone in here, I clicked Insert Variable Studio. In the Variable Studio, I created this width of base, and I'm just going to call that one length, or that's a dimension type is length, and the value is 66 here. here. So now what this means is I can go back into my sketch. Like I said, this dimension here actually is a static dimension at 66. And now I'm going to go to sheet metal, extrude that. So I hit the green check mark. We go sheet metal model. And then this is going to be extrude. And I'll pick on this line and this line. And then here for the depth, this is going to be hashtag width of base. So I can just press down and then press enter. And now that's going to become 66 for the width of the base. And I'm going to say that's going to be symmetric. And then I can press tab, get down here to my thickness 4, tab, get down here to my bend radius 4. That's shown on the drawing here. So note, default wall thickness 4, default bend radius 4, maybe modeled as sheet metal or as a thin walled solid. So we're going to do it as sheet metal, right? Because we're sheet metal pros here in Onshape. So now that we've got our sheet metal parameters in here, the one thing I want you to note about those sheet metal parameters is I use tab a lot. So I press the tab key on my computer to get to symmetric, press the space bar to activate symmetric, tab, get down to my thickness, press 4, tab, get down to bend radius, press 4. Awesome time saver in Onshape. And then the final thing when it comes to sheet metal is you just got to make sure that your material is going to the correct side. So you'll notice here that I've got my direction here of my sheet metal material. Make sure that that's going to the correct side. In this case, it's going to be going to the inside because of how I dimensioned this dimension here at 169, and because of how that dimension is on the drawing. So we hit the green check mark and boom, there is our sheet metal. Now we can do S key, fillet, and we can pick on this corner here and this corner here. And then for the radius of the fillet, we can type in hashtag width of base, enter, /2, enter. And look at that, nice full round fillet there based on the width of that extrusion. That is how you use a variable studio. And so I can press enter there and boom, we are done with that full round running around the top of that part. Now we can go into the hole command and we can say we want there to be a hole, which is just a simple hole with a diameter of 33, I think. Yep. 33. And then you can see here that we can align that hole using the select mate connectors option. So you click here, select mate connectors, and then you just kind of put your mouse near this edge and it'll kind of wake up the center point of that edge. If you just kind of get near that edge there. So there we go, and click, and look at that. There is our hole. Hit the green check mark. Boom, we are done with that feature. So now we can click on this face here, S key, begin a sketch, and we're going to create that kind of rectangular cutout for our jog relief. So S key, rectangle, and we can create a rectangle here like so. And then we can say that this point here, the origin, I notice when you're trying to pick the origin, I usually hover like right about here. So you notice like I'm kind of down and to the right of the origin. If you put it right over the origin, a lot of times you don't get it. You get like the line or the plane or whatever. But if you go just a little down and to the right, then you can left click and pick the origin, pick this, pick the line of the sketch. You want the line of the rectangle, and then Shift M, boom, midpoint. And then what we could do is we could sketch a rectangle here. So there's a couple ways we could do this rectangle. I'll probably just do it with a center point rectangle so I can get the vertical relationship here. So we can create a rectangle here like so. And now that rectangle is going to basically have symmetry both the rectangles are going to have symmetry relative to one another and relative to the part. So you'll see that if you hit escape and then you grab this one, see it behaves symmetrically, and this one behaves symmetrically as well. So that sets us up to add in our final dimension. So S key dimension, the width of that slot is 30. The width here to the clearance is 3, and that should get it for both of them. And the location to the cut is going to be our first dimension, which is the 24 location to the cut relief. And then the location to the beginning of the jog is going to be our second dimension here, which is going to be our 30. So once we create that geometry, we're ready to jump into an extrude cut. So S key extrude. Oh, sorry, guys. Let me go back to my top view. This is what that sketch should look like if you're following along with on a tutorial. I kind of changed that view pretty quick. This is probably what you want that sketch to look like if you're following along in the tutorial. So now you can see that I can go into S key extrude, and this is going to be an extrude cut. I'll hit the space bar to clear my selections, and then I'll just pick this region here, and that is going to be either up to next or through all. Either one will work. I usually just do through all if there's nothing behind it. So that gives you a great start for your jog that's going to end up coming down. Now, both the jog that's coming down and the tab that are sticking out here, both of them kind of go to this absolute floor location at 18 millimeters. So I think what I'm going to do here is I'm going to create a new plane at 18 millimeters down from the top plane. So I'm going to click on the top plane here, S key, plane. and then I'll tab 18, enter, and then let's flip the direction of that plane. So it's going down, enter. And then I could call this one either absolute floor, so shift N, or 18 millimeters plane down from top. Either one of those will work. But now I know that that plane is important. So there we go. We can see what that plane looks like. So now to create our jog, we could do our jog in two ways. And I'm going to show you both ways because I think they're both valid. So the first one is I could take this edge here, go to sheet metal, and then go to flange. And I can bring a flange down. Let's say I bring that flange down to a distance of, let's say, let's make the angle first. So I'll make the angle 60. And then I'm going to bring that flange down to a distance of up to entity. And you'll notice here I'm going to pick on this plane. And this is something, especially for you SolidWorks users out there, this is something that does not work well in SolidWorks. When you have a flange, a sheet metal flange going at an angle, and then you try to reference it to something else, SolidWorks always seems to struggle with getting the length correct. It's almost like it calculates the projected length, but not the length on an angle. But you'll notice Onshape has no problem. It just comes right up to that plane the way you would expect it to. Yeah, Matab in the chat says, yeah, SolidWorks is bad with that. Yeah, I've had to come up with many, many workarounds to get that to work in SolidWorks. So I just wanted to make sure that I pointed that out to you for all the Onshape users and all the SolidWorks users that are maybe getting ready to switch over. And so that works really well. And then the other thing you got to be careful of is this is where the original that 30 millimeter dimension was, and this is where the flange is currently beginning. So we adjust that using what's called our flange alignment. So here, if you adjust that flange alignment, if you want it to go to exactly where the geometry originally was, you use this one here, hold bind. So hold bind, that way it's starting, just like it shows on the drawing, it's starting right there. So we hit the green check mark and boom, there is our flange. Now for our second flange, what we could do is we could pick this edge here and then we could do flange. And you'll notice here that we're going to make this again at 60 degrees and we'll just flip the direction of that flange. And there we go. And then for the length of that flange, for this example here, it's kind of arbitrary. You'll see why in a moment. But let's just say I make that 100. I'll just make it a random amount. And again, you'll see in the second half of this flange definition, I'll show you kind of how I got that, or what I will do with that, how I'll cut that off. What we'll do is we'll go in and we'll just cut off this shape here with a little half circle and then a hole going through it to create the lower part. But we're not there yet. The one thing I want you to notice here is that because we created this plane down below here at 18 millimeters at absolute floor, we don't even need to necessarily know what each of these options does for flange alignment. We could just kind of guess, like inner, outer, middle, hold line. Well, which one looks like it's got the flange exactly on the floor there? To me, it looks like it's outer. So if we just go to outer there, boom, we got ourselves a flange that's right there on the floor and we are good to go. So that's kind of a cool way of using that plane as a reference. And then we can also use that plane when we go to create this flange that's sticking down here, the little leg that's sticking out on the side over there. So that's method one. Do it with two flanges like shown there. Method two is we could do it with a sketch bend. And I really like this one. So I'm going to go back to flange 2 and delete it. Now, flange 1 is pretty good as it is. I'm just going to change the length of flange 1. So instead of going up to entity, I'm going to make it blind and I'm going to make it 150. It's just an arbitrary amount for that distance, 150. See, it's sticking way down there. So then what I'm going to do is I'm going to hit the green check mark. And now I'm going to create a new sketch here on this plane. Remember, this is our plane that is the 18 millimeter floor plane. 18 millimeter floor plane. So begin a new sketch there on that 18 millimeter floor plane. And once I begin that sketch, I'm going to use a command called intersect. Now, intersect is found here underneath the use command. So you've got use and then you've got intersection. And what this does is it lets us create a line wherever this face, I'm going to pick the face, wherever this face is passing through the sketch plane. So wherever that face is passing through, we end up with a line. So I'm going to do intersection, and then I'm going to pick this face here, and look at that. Onshape goes in and it adds a line exactly where that 18 millimeter plane is passing through. And so now that I've got that sketch there, I'm going to exit that sketch, and I'll rename that sketch to sketch bend line. And then I'm going to use that sketch with the sheet metal command bend. So by clicking the background, if I go in here to bend, I'm going to pick the bend line, this sketch here, and then for my sheet metal face to bend, I'm going to pick this face here, and look at that. And now we're basically right back to where we were with the 2 flanges. I just wanted to show you guys 2 different methods, because if you're learning sheet metal, it's good to know as many different methods as you can, because they will all come in handy at some point or another. So we'll change this to 60 degrees for that bend. We'll change the direction of the angle, the opposite angle, and we will adjust the bend alignment. Bend line, hold other line, inner, outer, and middle. So where do we want this one? We want this one on outer as well. And there we go. And we hit the green check mark, and boom, that takes care of that geometry. And so now the only thing that's really left to do is just to clean this thing up with a cut extrude. So I'm going to pick this face here, S key, begin to sketch, N key to get normal to. I'll create a rectangle here, rectangle like so. And then I'll create a circle at the midpoint of that rectangle. So that circle is going to have a diameter of 10 millimeters, and then another circle like so. And then I'll create another construction line. So from here to here, we'll do a construction line. And then we'll say that that construction line is going to have a distance from the center of the hole to that construction line crossover to get our double dimension of 50 millimeters. And then we can go S key extrude, and this is going to be a remove, and we'll do this one through all. And then we'll say that we want to just hit the space bar so that we, through all, hit the space bar up here in this box, in your selection box, so it clears everything. And we want to get rid of this, and this, and this. And boom, look at that. That is looking good. So now the final thing we need to do is just add that tab over here on the outside. So we pick on this tab here, and we go to our sheet metal command for flange. And the thing about the sheet metal command for flange is, once again, we have to take a look at where the flange is beginning. So we want it to begin right here. So that is going to be hold line. Hold line is original geometry. So the original edge, that's where we want it to begin, hold line. So we fly out this menu here, we say hold line, boom, now it's using the original geometry. For the depth, we could say we want that to go up to entity, and we can pick this 18 millimeter plane. So that way the flange goes right down to that plane. That's pretty sweet to reuse that plane. And then for the length of this thing, we're going to say partial flange. Now, the thing about sheet metal in Onshape with partial flanges is this distance by default is this distance here, which is not what we want. So that distance there is 10. You'll see if I change that distance to 15 or 20, it increases off of that edge. So instead, what we want to do is we want to change this to end condition up to entity with offset, and then you just pick this point here where you want your dimension to begin. So our dimension that's shown on the drawing there is 31.5. So if we make this 10, you can see it's getting bigger, 20, and then 31.5. I only did those increments so you could see what's going on with it. And then remember, in Onshape, you can pick both edges at the same time. So I can also pick this edge over here. So if I come back up to this box where you pick your edge for the model, I could pick this edge over here too, and look at that, boom, we get both of them at the same time. Oh yeah, that's good. And then finally, the top secret filleting shortcut here. When you're doing fillets, you can do a window select and get all the fillets that are in a row. And that's a good shortcut to remember. So you can see here, we've got these 2 edges here. So I go S key, fillet, tab, 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 make that 10. And then I put a little window here, and oh yeah, look at that. We get both of them. We like that one. And so we can do the same thing here for the, that radius is going to be 10. So we can do the same thing here for this other one, window, that guy there. And oh yeah, that looks good. And there are our fillets. So to finish this thing off, we'll use our mirror shortcut that we learned a couple of Onshape tips ago. Pick that face, S key, mirror, tab, pick that face again, and then just choose add and hit the green check mark. And then we can go over here to our part 1, right click, we can say assign material. And we're going to assign the material from the Too Tall Toby custom materials library, and make sure that you're using the correct material here, plain carbon steel from the Too Tall Toby custom materials library. And then we're going to go down here to our section, our properties down here in the corner, mass and section properties. Click on that, click on the part, and we are coming up with a mass of 559.69 grams or 559.7 grams. And so let's go back to the Too Tall Toby app here. So we'll go back here to the Too Tall Toby app. The timer is still running on this app, 21 minutes. Let's see if we got it correct. Wait, what was it again? 559.7? I think that's what it was. 559.69. Enter. And oh yeah, we got it correct. Whenever we see that purple screen, that lets us know that we got it correct. So congratulations, this answer is correct, and that is your sheet metal live solve for this episode of Model Monday Live. Remember, you can always join us on Model Monday Live to take these challenges yourself and see if maybe you can model this thing faster than me. But if we take a look here at this model, this challenge, this 0710 SM Lifter Challenge, we can see that 12 people have completed this model during the live stream. Who is it that completed it first from the time it was released? Well, we can find that out here on the first 42 leaderboard. So we can see that this model was originally posted at 1:37 p.m., and within 5 minutes and 46 seconds, it was none other than Sebastian MCGA from Germany who finished that model using CATIA. And whoa, look at this, a little bit of foreshadowing. This Friday, we're going to see Sebastian go up against Gray in our CAD vs. CAD tournament. And Gray was our number 2 finisher here in 5 minutes and 54 seconds. Wow, guys, less than 10 seconds apart from each other. Wow, wow, wow. That is some speedy modeling. Rambro's Workshop, our world champion of 3D CAD speed modeling, finishing in 6 minutes from the time it was finished. Metab finishing 8 minutes from the time it was finished. Lotos 10 minutes from the time it was finished. Wow, you guys are so speedy. EcoStang is here in the live stream doing these challenges, 11 minutes using SolidWorks. Gummy, a fellow Onshape user from South Africa. What's up, Gummy? Finishing in 18 minutes. Well done. Dom, 19 minutes. And Libe